Section 2.1, example 3, finding the area region bounded by functions that cross. Ooh. So if R is the region between the graphs of the functions f of x and g of x over the interval from 0 to 1, find the area of the region. They're using different language here, so that makes me feel that there's going to be something a little fishy here. Let me graph it for you guys really quick. I'm back. Okay, so let's do the same thing that we did earlier. F of x is, oh, now the colors changed a little bit. So f of x is now this purple function, our sine graph. G of x is now this red function, our cosine graph. So let's see when f of x is less than y, less than g of x. Ooh, so there's where we have a function. So it's looking at all of our values for y, where f of x is a smaller function and g of x is a larger function. So when g of x is on top. So it's a little different there. Let's see. Let's see what it looks like when it's opposite. G of x is less than y, which is less than f of x. Okay, so now we have a bit of a problem. So now we have two regions. Actually, let's just make sure. Let's restrict it from, our restriction was from 0 to pi. So 0 less than x less than pi. So pi for pi. Okay, it doesn't look like it's too different, but we do have to be careful of those regions. Again, so from 0 less than x less than pi. Okay, so not too bad. What we're going to have to do is integrate two different functions. So integrating the first one here, this blue region, and integrating this second region over here. The way we find this is when we set the two functions equal to each other. If you see here, it's going to be pi fourths, which, let's think of our unit circle. The only time cosine and sine are equal from 0 to pi is right there at pi fourths, where like it kind of represents our 45, 45, 90 triangles. That's the only time where the two are going to be exactly the same. So let's get back to computing and see where we have those equal to each other. So starting off our first area, so our area is going to go from 0 to pi fourths, where the two are equal to each other. And in this region, we start off with our top function being our cosine function. So we have cosine x, and we're going to subtract the bottom function, sine x. So cosine x minus sine x dx. We have to add that other region, the second one. This one's going from pi fourths all the way up to pi. This time they're switched. So sine is now the top function. So here we have sine x, and we're subtracting all of the cosine x. And let's get to integrating. So the derivative of the integral of cosine is sine. So sine x. The integral of sine is negative cosine, so that's going to be a plus cosine x. And here we're integrating from 0 to pi fourths. We're going to add that second integral. So this one's going to be from the integral of sine, which is negative cosine x, minus the integral of cosine, which is sine. And we're integrating all of this from pi fourths up to pi. Get rid of that parentheses. All right, so looking at those two, let's start with this one first. And we're going to evaluate pi fourths first. So sine of pi over 4 plus cosine of pi over 4. We have that. Now we're going to evaluate at 0. We're going to subtract sine of 0 minus cosine of 0. And now that we have everything, all of this here is done for this. Let's work on this one next. So starting off with evaluating it at pi. So plus we have negative cosine of pi minus sine of pi, and subtracting that from negative cosine of pi fourths minus sine of pi fourths. Let's evaluate. Sine of pi over 4 is our root 2 over 2. Cosine of pi over 4, root 2 over 2 as well. Sine of 0, you get my unit circle here. So sine of 0 is 0 there, so minus 0. Cosine of 0 is 1, so minus 1. Plus we have negative cosine pi. So now pi is over here. Negative cosine of pi is negative of negative 1, which is positive 1. And yeah, right there. So positive 1 sine of pi is going to be 0, so minus 0. Minus, here we have minus pi 4, or cosine of pi fourths, that's going to be a negative root 2 over 2. Negative sine of pi over 4 is a negative root 2 over 2. And now let's get to simplifying. Here we have 2 root 2 over 2, so that's just going to be root 2, minus a negative 1, which is going to be plus 1, another plus 1. And then in here we have negative 2 root 2 over 2, so we have negative root 2 times negative is going to be a positive root 2, so plus root 2. And we have 2 root 2 plus 2. And I feel like I messed up somewhere. Just a sec. I think I found it. So looking at this, it should be sine plus cosine. Sine plus cosine minus sine plus cosine. This shouldn't be a negative, that should be a positive. So plus 1, making this first one negative, getting rid of this right here. And that matches. Perfect. Now, if you have any questions, please feel free to ask. Otherwise, bye.